Okay, in this video we're going to look at graphing some quadratics. We're first going to look at plotting some points just to get an idea of what's going on, but we want to move away from plotting points ideally. So let's start with x squared or y equals x squared or f of x equals x squared, any of those. And let's look at a table of values just to get an idea of what's going on. So we're going to plug in x, we're going to get y, and we're just going to look at a few values here. So let's say we've got -2 to +2, and when we plug those in, we're going to square them and they're all going to come out positive. So we get +4, +1, 0, 1, and 4. That's a 2 there. Let's go ahead and graph that. So we've got some points. We've got 0, 0, 1, 1, 2, 4. We've got -1, 1, -2, 4. And if we plotted more points, we would see that these aren't lines, they're actually curves. It flattens out a little bit until 1, and then it starts to get steeper like this. Let's try that again. There we go. It's going to keep getting wider, but it's going to be harder to see it. Oh my goodness, it's a little bit hard to graph on a tablet. There we go. Okay, so if you wanted to, you could plot a whole lot more points than this, but x squared is one of the basic graphs. You've probably seen this before. So it's U-shaped. Make sure that's not V-shaped. It needs to be U-shaped. Let's try another one, and let's look at y equals x squared plus 2. Okay, y equals x squared plus 2. So we see the x squared, but what does the plus 2 do? So let's make a table of values again. And I'm going to plug in those same values. And this time when I plug it in, I'm going to square it and then add 2. Okay, so I'm going to plug all these in. Alright, so you see it kind of looks the same for all of them. For all of them, we're going to square it and then add 2, square it and then add 2. That's what order of operations say. So we're going to get 4 plus 2 is 6, 1 plus 2 is 3, 0 plus 2 is 2, 1 plus 2 is 3, and 4 plus 2 is 6. Now you might kind of see a pattern emerge here. If we compare them to our values over here, we plugged in all the same x values. And if you look at our y values, this first part right here, that's what we had in the first table. And then we just added 2 to all of them. So you can see we had 4, 1, 0, 1, 4, and now we have 6, 3, 2, 3, 6. We added 2 to all of our y values. Alright, so think about what happens to a graph if you take all the points in your original graph and then you add 2 to all of the y values. Add 2 to all the y values. So what was 0, 0 is now 0, 2. This one goes to 1, 3. 2 goes to 2, 6. I'm actually off the graph a little bit. 1, 3, and 2, 6. So if you look, if you add 2 to all the y values, all of your points shift up by 2. And again, we're only plotting a few points, but it would work the same for any points that we wanted to plot. So we can make this table as big as we wanted, and we would see that it adds 2 to all of our y values. Okay, so what do we think would happen if we take x squared and we do -1? X squared minus 1. So again, let's look at those points. Okay, and I'm just gonna go ahead and do it in my head. So I'm gonna get 4 minus 1 is 3, 1 minus 1 is 0, 0 minus 1 is -1, 1 minus 1 is 0, and 4 minus 1 is 3. Okay, and hopefully that's what you expected. Look at our original column and look at our new column. All of our x's stayed the same, but all of our y values went down by 1. They went down by 1. So that should shift the whole graph down by 1. Okay, so if you take all of your y values and you do -1, that's going to shift all of your points down by 1. So in all of these, we get the same exact picture. At least it should be, limited by my drawing skills. We get the same exact picture. We're just shifting them up and down depending on what that number is that's added to it. Okay, so let's do one more. Let's say we wanted to do, without plotting points, let's say we wanted to do y equals x squared minus 3. Y equals x squared minus 3. So that's going to shift it down by 3. Okay, adding shifts up, minus shifts down. So we're going to shift down by 3. Okay, if you want, you can actually shift these points down by 3. Whoops, I shifted the wrong one. Shift these points down by 3, or you can just use this point and the general shape of it and fill it in. Okay, so the idea is to try to move very quickly beyond having to plot points for every single function that we come across. And this one is really common, almost as common as linear, so we want to be comfortable with it. Okay, so the general rule is x squared plus c shifts up c, and x squared minus c shifts down by c. Okay, so I've given us a fresh start here. We've got our first rule that we learned up here, and let's look at another one. So we know what happens if we add or subtract a number like this. What if we add or subtract a number inside the square? So let's try that. Let's say we've got y equals x minus 1 squared, like this. Alright, this one's a little bit harder to see what's going on, but as long as you get the general idea, that's what we're hoping for. Alright, so we're going to plug in all those same values, and let's see what happens. So when we put negative 2 in here this time, order of operations says we've got to do what's inside the parentheses first, and then square it. So I'm going to have negative 3 squared will give me positive 9. Negative 1 gives me negative 2 squared is 4. 0 gives me negative 1 squared is 1. That gives me 0 squared is 0. And this gives me 1 squared is 1. Now it's a little bit harder to see what's going on here because there's no real discernible pattern yet. But if I go one more in my x values, maybe you'll see a pattern then. So this is going to give me 2 squared is 4. Now this time our y values actually stay the same. If we had a huge table of values, you would see that all the y values match. They just line up with different x values this time. So see that 41014? Okay, it repeats. All of the y values will be the same, they're just a little bit shifted. So they go to a different x value. So now what's happening to our x values? We go from negative 2 to negative 1, negative 1 to 0, 0 to 1, 1 to 2, 2 to 3. We are adding 1 to our x values to get the same y value back again. And that's because of that minus 1 right there. We've got to add 1 to make up for it. So this one's a little bit backwards from what you'd expect. When you go to graph this, oh, we lost our x squared graph. Let's put that back in. Okay, here's our original graph. Like this. Okay, and we're going to graph our new graph, and if you think about it, I've said all my x values are going up by 1. We saw what happened when the y values all went up. What happens if all the x values go up by 1? Okay, think about what that's going to do to it. Let's see. So we're going to have negative 2, 9 is going to be off the graph. Negative 1, 4. We've got negative 1, negative 1, 4, 0, 1, 1, 0, 2, 1, 3, 4. Okay, if you look, adding 1 to all of our x values shifted us to the right by 1. Shifted us to the right by 1. So let's go ahead and graph that in. Okay, so we shifted everything to the right by 1. But if you come back to this original function, look at this. It's a minus 1 inside the square. Normally, when we see minus 1 in math, that goes to the left. We think of negative going to the left, positive going to the right. But this is going to be backward. What's actually happening to the x values is the opposite of what is inside these parentheses. So when you see negative 1, it's actually shifting to the right by 1. Okay, we're actually going to shift to the right by 1. Let's try y equals x plus 1 squared. Okay, so I'm just going to go ahead and do -3, -2, -1, 0, 1, 2, because we're going to need that -3 to see how it matches up. And I'm going to plug it into my head, so I'm going to get -2 squared is 4. -2, when I plug that in here, I get -1 squared is 1. Plugging in -1, I get 0. Plugging in 0, I get 1. Plugging in 1, I get 2 squared, which is 4. And plugging in 2, I get 3 squared, which is 9. Okay, so let's look at what happens with the red graph. Again, we see that 4, 1, 0, 1, 4 pattern. But this time the x values have all gone down by 1. Okay, the x values have all gone down by 1. So that should shift us to the left. And that's backwards what we'd expect. +1 we would think would shift to the right, but it actually shifts to the left. And then when we graph that, we'll see that that is the case. Oops. Okay, so we don't want to plot points anymore. Let's talk about the general rules for a second. So we have this one right here. Okay, and that's that if we add or subtract outside of the square, we're going to go up or down. And then the other general rule is if we add or subtract inside the square, we're going to go left and right, but it's backwards what you'd expect. So plus c is going to shift us to the left, and minus c is going to shift us to the right. Okay, so that's the general rule. If you add or subtract outside the function, it shifts up and down. If you add or subtract inside the function, it shifts left and right. And what's cool about this is it actually works for any function, not just squares. You can use this to graph anything.